Hello everyone. After doing some sessions on permutations and theorems, in this session we will be doing some illustrations. So my first illustration is that find the number of 3-letter words from the letters of word chair. Now chair has 5 letters in it and we are asked to find arrangements of 3 letters. 3 letters out of 5 letters. This reminds us one theorem we have done. What was that theorem? Theorem was our second theorem, that you arrange R objects out of N objects, and it can be done in, yes, N factorial upon N minus R factorial. This was the theorem which we'll be using for this particular question. And our required number according to theorem 2 should be 5p3. Now 5p3 means 5 factorial upon 5 minus 3 factorial, which is 2 factorial. So 5 factorial upon 2 factorial. So answer should be, after simplifying, 5 into 4 into 3, which leads to 60, which I have written directly here. I hope you understood application of that particular theorem 2, which we had not done in the previous session. Now I go for next illustration, and the next illustration is find the number of permutations of the letters of the word entrance so that all non-repeating letters are together. Now this wording itself takes your attention. All non-repeating letters means there are some repeating letters. Which are those letters? N and E are repeated. Means 2 N we have, 2 E's we have, and then TRAC comes single. Now we are asked that TRAC should be always together. So we can arrange TRAC together if we wish. So this is equivalent to N distinct objects you arrange in N factorial ways. So using this theorem 1, we will be actually arranging now TRAC that can be done in 4 factorial ways. Now what about 2 E's and 2 N's? We have to take attention to those also. And 2 E's and 2 N's are repeated ones. So is it not something similar to theorem 3? Theorem 3 we had repeated quantities and we divided by factorial of the numbers which was giving you the repeated quantity, right? So here in this problem, since 2 E's are repeating, so we will have to divide by 2 factorial. 2 N's are repeating, so we'll have to divide by 2 factorial. And the thing is, we have now 2 E's, 2 N's, means in all 4 letters, and TRAC together as a tied. So 5 quantities are there. Normally we would have written answer as 5 factorial, provided letters were not repeated ones. Here since repeated ones are there, so we divide by 2 factorial, 2 factorial. This gives me answer as 30 on simplification. Question is not yet over. We are just saying TRAC together. Together, they themselves inside can be arranged in 4 factorial ways, which I have written there. We have not yet utilized that. So my final answer should be 4 factorial into that 30. So answer is 720. So this particular example actually is application of many things, like theorem 1 is also appearing there. Theorem 3 is also appearing there. Not only that, inside also, like 4 factorial, what we were saying, the TRAC, they themselves can be arranged. Even that, like alertness is required. You just do not write your final answer as 30. One of the options from competitive examination point of view, I'm saying, would surely be there 30, because they also know that many students will just take on 30. So be alert while answering questions related to permutation combination. This particular example tells you that, right? So let us move to next illustration. And next illustration is with 10 different letters, 5-letter words are to be formed with or without meaning, and the requirement is that at least one letter is repeated. Now whenever it comes as at least, you can go for indirect method of counting. You remove those cases which are not required from total number. That is way of counting for at least. Because otherwise at least one letter repeated means you can say 1 letter repeated, 2 letters repeated, 3 letters repeated, like it would be too many cases. So just to make answer short and sweet, we go for that from total number of cases you remove which is not required. That is called indirect way of counting. Okay. So we proceed for the solution part. And total number of words from repetition, no repetition, whatever. So 5 letters are there, means 5 places are there, 10 options for each. So using multiplication principle, I can say 10 raised to 5 words can be formed. There may be all 5 letters repeated also. I don't care right now. I'm just saying total number of words. That would be 10 raised to 5. Now from this number, we will have to remove something. What we will be removing? Which is not required. Correct? And for that, we will understand that we need to write now 5 distinct letters kind of. 5 places are to be filled with 10 distinct numbers. So that number which we want to remove is going to be 10p5. Correct? Now this 10p5 needs to be subtracted to get required number from 10 raised to 5. And how do we simplify this? From competitive examination point of view, perhaps actual answer may be in this form only. Options may be written in terms of 10 raised to 5 or 10p5 or 10 raised to 5 minus 10p5, means p notation occurs there. From competitive examination point of view, I am saying. But if it is written examination, then you will have to simplify that 10p5 also. So how do we simplify? So we take 10 common, 10 raised to 4 minus that 10p5, we know how to write it as 10p5 is going to be 10 into 9 into 8 into 7 into 6. So remaining part 9 into 8 into 7 into 6 remains inside, and you can simplify it further. And answer finally in the simplified form would be 69760. That would be the answer. Now this is regarding indirect method of counting. Correct? Now let us proceed from here, and one last theorem on permutations I take here. That is called circular permutation. Now here I am showing few arrangements in which objects p1, p2, p3, etc. are kept, right? And pn also. What I am doing is, next to p1 I am writing p2, next to p2 I am writing p3. Like that I am showing here. And then what happens is that it is like some threads you have kept, and then you are allowing it to, like put it in circle form. Will you get different circles? No. Arrangement still remains same throughout. So all n arrangements in linear form are equivalent to one circular arrangement, right? So what happens is, such arrangements in linear form we count n times. So in circular permutation we will have to take care, and the care what we take is the total number of circular permutation of n distinct objects would be now n factorial divided by n. Why? Because each particular arrangement of n objects in the same order gets repeated n times. So we need to divide by n. So n factorial upon n. So number of circular permutations would be finally n minus 1 factorial. Now one more thing you can remember if you want to, that what we do in circular permutations to treat it as if like it is linear permutation. What we do, we tell one person or one object to go and take its place. That can be done in one way only, because all the places are just alike for that first object. Once that is attained, then actual orientation is required. Means remaining n minus 1 objects are to be arranged. So finally answer is n minus 1 factorial. You can understand it in a different manner also. So anyway, I will take your leave from here now. Till we come again, till then stay tuned. Thank you. Hope you have liked the video. If you want to subscribe, click on this side. And if you want to place order for the book, click on this side. Thank you.